This is Softwarible Bytes. Hello and welcome to a new episode of Softwarible Bytes. This is the show where I read to you from various blogs out there on subjects like software and cloud engineering and architecture, site reliability engineering, DevOps, and everything in between. These are topics I'm passionate about, and if you are too, then this podcast is for you. In today's episode, I'm reading to you from Kong blog, an article titled How to Develop a Cloud-Native Infrastructure by Garen, Torikian. How to Develop a Cloud-Native Infrastructure by Garen, Torikian. This article is published on konghq.com. More and more companies are eager to move their operations to the cloud. Yet there is a bit of ambiguity on what moving to the cloud actually means. Is your business running in the cloud while you host your database on another platform, or while you rely on a third-party service to handle your payments? That's a good start for moving to the cloud. But there are many other aspects to consider when building a cloud-native infrastructure. Embracing a cloud-native infrastructure requires you to rethink how to build, deploy, and run your software. The Cloud Native Computing Foundation, CNCF, defines a cloud-native infrastructure as one of the containers, service meshes, microservices, immutable infrastructure, and declarative APIs as typical characteristics. This begins with isolating services within your application and moving towards decoupled and secure microservices. Further, a cloud-native infrastructure requires automation through continuous delivery. Lastly, your ability to leverage containerization will go a long way toward moving you to the cloud. In this post, we'll take a closer look at these key features of a cloud-native infrastructure. Beginning with service isolation. When it comes to architecting an app, there are often two competing organizational methods: monoliths and microservices. A monolith is a form of organizing software in a single code base. Every feature and aspect of your app is self-contained. Designing microservices involves setting up separate, smaller applications. Each small app controls a single aspect of your app's functionality. Transitioning from a monolith to microservices. Cloud-native infrastructure doesn't need to be a collection of microservices, but sooner or later, you might find yourself needing to scale out one part of your application. Monoliths are easy to get started with, but after a certain growth stage, microservices become easier to administer and configure. If you change one microservice, the worst-case scenario would be taking down a single feature. In a monolith, a change could impact the entire application. This almost forces you to think about application design in different terms: redundancy and message queuing, anticipating and recovering from errors, aspects which a monolith application obscures. In other words, the failures on one service do not affect any other that makes up your application. Facilitating communication between microservices. Microservices communicate by passing messages and data through APIs. We don't typically expose those APIs to the public. Nonetheless, you could set up an API gateway through Kong Connect to help route external requests to internal services. An API gateway provides a big picture overview of how services interact with one another and the outside world. The communication protocol used in a cloud-native infrastructure does not matter much. You could use REST, gRPC, GraphQL, or anything else. What does matter is using a consistent standard and ensuring all commands pass through the channels. Keeping security in mind. Isolating your app's functionality into microservices provides other security benefits as well. Earlier, I mentioned how buggy code would only affect one microservice. The same is true for larger problems, such as security issues. If an external agent gains control of one server, they are less likely to hop to another server due to network isolation rules. You can apply these rules across your entire infrastructure and manage them from one location. In a true cloud-native infrastructure, even your database acts as a microservice. It prevents storing user data locally. Kong Mesh and the CNCF's open source Kuma grant observability of traffic rules, logs, and permissions to maintain the strength of your cluster. Automating with continuous delivery. Deployment and delivery for a monolithic application can be cumbersome, brittle, and time-consuming. Moving toward a cloud-native infrastructure means moving toward a DevOps approach. That means automating all aspects of application delivery. Independently update microservices. With your services separated, you can now update each one independently. Here again is another advantage of microservices over the monolith. A monolithic application might have thousands of tests that take time to complete. The deployment might also take a long time as services restart and dependencies update. With microservices, your application separates into individual code repositories. Updating one aspect of your app is much faster because everything is scoped and isolated. Your test suites are smaller and language dependencies are fewer. Infrastructure as code. You've likely already embraced a DevOps mindset, which is a requirement for a cloud-native application. In this step, all aspects of infrastructure management, deploying the code, load balancing your servers, scaling your resources, etc., are performed with scripts. This turns your processes into testable, versionable pieces of code, and it helps ensure that applications are modified and upgraded consistently. Interconnected scaling and monitoring. For a cloud-native app, all of your data stores, servers, and other resources should be able to expand or reduce at any moment. If you run out of disk space on one microservice, the process of enlarging the disk should be repeatable for any other microservice too. This will lead to a situation where infrastructure management could even tie into your monitoring software. As your monitoring solution detects the need for more resources, it alerts your infrastructure management system to scale up the necessary resources. For example, imagine a situation where your monitoring system sees increasing traffic for a certain service. With scripts in place for automated processes, the monitoring alert can trigger a service deployment to additional nodes to handle the uptick of activity. Or perhaps an erroring incident occurs on a service. The monitoring system can trigger the process of locking down that service for troubleshooting while spinning up a separate service to handle subsequent requests. All of this is possible because each of your microservices focuses on one task. You can modify the behavior of each microservice through API calls. Leveraging containerization. By understanding the above requirements, containerization becomes a more reliable approach for setting up and running your app. Running your application in a container allows you to build software with greater consistency, elasticity, and predictability. The operating system and any system packages are explicitly defined and managed by code through Docker. A container is built from a Docker file, and Docker Compose is used to coordinate the starting of multiple containers. In production, however, orchestrating your microservice containers will lead you to Kubernetes as a way to manage all of your nodes. It comes with many advantages out of the box. For example, if one node fails, Kubernetes can automatically replace it with a healthy one. Kubernetes can handle load balancing across your network, and it can scale out resources based on usage. The interesting thing about Kubernetes is that it's driven by APIs and CLI tools. This is immensely helpful for automation, but it's less useful if you're a human trying to get an overall picture of your network health and operation. This is a gap that Kong Connect fills. Kong Connect and most Kong services keep Kubernetes open protocols in mind. Rather than replacing Kubernetes, Kong works alongside it. The main focus of Kong Connect is to ensure services are reliable and performant. Kong Connect does this by providing observability into services, giving insights on uptime and traffic patterns, as well as the devices your users are connecting with. You just listened to How to Develop Cloud-Native Infrastructure by Garen Torikian, published on konghq.com. Cloud Native is an approach to build and run applications leveraging the cloud benefits such as scalability, agility, and cost optimization. Garen laid out the major steps for succeeding in the migration to the cloud. I think starting by gauging and weighing your existing situation is a good start. Then transitioning into microservices and leveraging containerization. As the article pointed out, the benefits you reap from that, such as scalability, flexibility, and faster and more efficient app development. Pairing that with continuous integration and continuous delivery to deliver new features faster. And that's something every organization would love to have because it means faster time to market and the ability to scale seamlessly for the demanding customers while still optimizing for cost. And since incidents are inevitable, we always need to be on top of everything by increasing the visibility in the system through observability, monitoring, and alerting. All of that while keeping security in mind every step of the way. If you are considering migrating to the cloud and you would like to get consultation on that, reach out to us on softwarible.com. We help customers in their software and cloud journey. Whether it's taking software from ideas to complete solutions or migrating existing systems to the cloud, we make it work for your needs. Now, it's time to check the tool of the day. Today's tool is Crew. K-R-E-W. Crew is the plugin manager for kubectl command line tool. It helps you discover kubectl plugins, install them on your machine, and keep the installed plugins up to date. Crew works across all major platforms like macOS, Linux, and Windows. It's a project under Kubernetes Special Interest Groups organization in GitHub, so you can find it there at github.com/kubernetes-sigs/crew. You'll also find the link in the description of this episode alongside the link of today's article. And so that is it for today. Have a happy rest of your day, and I'll see you here in the next episode.